discuss systems in analog communication. Okay, we only discuss several. The first one is AM transmitter. We have a modulating, let me see, draw this one. Modulating signal source. Modulating signal source means the message you want to transmit. For example, for AM, usually it's the voice, the talk show, right? All the music for FM, but we talk about AM, so talk or the music. Anyway, so this is the signal we want to transmit. Then we have a band pass filter. A band pass filter is just eliminate the noise. The reason is we want to make sure the signal is band limited, so later time, because we know the power of the noise depends on the bandwidth. The power of the thermal noise equals, still remember this? K, temperature, bandwidth, right? So it's proportional to bandwidth. We just want to eliminate the out band noise. Bandpass filter is always a good practice. No matter where you are, you can just put a bandpass filter. Right? So only let the frequencies that we are interested in pass. All other frequencies just, because in any communication system or even any systems, you always have some like thermal noise or something or other noises. You don't want that. Right? It makes your system unstable. So you just put some bandpass filters anywhere you want. Usually not. Only is not bad idea. Then we have preamplifier. What's the purpose for preamplifier? Make resistance, impedance matching, and also most importantly, we mentioned this when we discuss noise figure. Reduce the overall noise factor of the system, right? We want to choose a quality device here, so make the overall noise factor reduced. Then we may have some drivers, modulate the signal driver, right? Driver amplifier. This is nothing, just make the signals even stronger. Right? And there's another one, it's called power amplifier. This one is just like a little bit increase, and this one is power amplifier. So that's, the gain is even larger. Anyone knows the difference between all this? Have you designed any amplifiers by yourself? I know you analyzed the amplifiers, right? Have you ever designed? This is a power amplifier, means, for example, to drive your speaker. This one usually in the watt or kilowatt. If you, for example, drive the speaker for the big stadium, that one is very large. You need a lot of power. The design principle will be different. This one you only you care about the, for example, impedance, the quality. This one, right? The power will be large. Or usually when we design linear amplifiers, we said the amplifiers are linear. That means for small signals, and those are large signals. So when you design this, it's a little bit different than this part. Right? So we need to be careful. But this, again, in this class, we do not discuss the design of all these systems. So we just mentioned it. Preamplifier, driver, and power amplifier. So after this one, the power at the output here is pretty large. And we have here the RF oscillator, carrier, oscillator. This one, for example, if I use my voice, that one will be from 0 to 20K at most. Right? So this one here, from 0 to 20K. And this carrier, like when you tune to listen station 950, that's 950K. Right? So this is called a carrier, 950K oscillator. How to generate this oscillator? You can use a LC or anything else, or even use a frequency synthesizer, right? We mentioned this. And this one, then we have a buffer. Buffer again is just an amplifier, right? And we have a driver. And we have a power amplifier. Once we have this tool, and we use a modulator. Modulator, as we mentioned, we are going to discuss the details in the following chapters. Modulator is just a multiplier. So we know it can be called a phase detector, can be called a phase comparator, can be called a mixer, but here we call modulator. So you can see the same thing can have different names at different conditions. Once you have modulator, then we go this way. It's called a band pass filter. Okay, again, reduce the noise. Then we have matching network. You already make the impedance matching. Then here we have an antenna. We connect to antenna, then we get out. So that's it. That's the AM transmitter. If you want to set up an AM station, transmitter by yourself, you just follow these diagrams. Okay.
Is that matching network?
Yeah, matching network. Network. This is the transmitter. Next one we discuss a receiver called AM super. Super heterodyne receiver. This is very famous, like 70, 80 years ago. Invented at that time. This is receiver. First time we have antenna, we receive the signal. Then we have a pre-selector. Pre-selector is just like this. Okay, we change this. And this one here is a RF amplifier. Then we have this one will control this part also. This one is a local oscillator. And this two let me draw this first. Alright. If you have the old style receiver, when you choose a station, you need to turn a knob, right? Alright, that is this thing. What you do is actually you change the oscillating frequency of your selection network. That means you choose which station, which input frequency. And at the same time, you have, this is called a GAN switch, something like that. Right? You turn this local frequency, oscillator frequency also, to make this change at the same time. Right? Once you choose a frequency, the signal from the antenna will be chosen and input to an RF amplifier. So the signal will be a little bit stronger. Then the oscillator output here will input at the same time to a mixer. Right? So what you have is this frequency, for example, you said 950, and this one maybe equals, for example, 485, K. This is the K. Then we mix, means this signal multiply together, and we choose the difference band pass filter, and this one will be called an intermediate frequency. Intermediate frequency, RF. RF means a radiated frequency. That means a radiated frequency, very high frequency. This one is called the intermediate frequency. And this is called the audio frequency, even lower. And this is the IF amplifier. Then we have audio detector. Audio detector actually is only a demodulator here. And so actually is again a multiplier mixer. Then we use the audio amplifier to drive with the speaker so you can hear the signal. Okay? So this is a super heterodyne receiver. Before that we don't have this one. You have this, you choose this one, you multiply, then you don't have this one, you amplifier, then amplify again, then you do this. This part will change for each station. Right? Now the beauty of this system is when you change this one, you change this at the same time, but to keep the difference the same. Right? So look at here. This is 950. This one 485. What's the difference? The difference is 555 kilohertz. Right? In this case, 565. Right? Okay. So maybe I will choose another. So this one minus this gives us 455 kilohertz. So this is called the intermediate frequency. It's lower than the RF. And now everything works. Next time you choose another station. For example, you choose this one to 960. What happened here? This one will change to 505 at the same time because this connected. You turn this, you turn both. The beauty is here. Makes difference is still this. That means for different channels, you have the same intermediate frequency network. All these drivers, amplifiers, and everything the same. So we don't need to change anything here. So that means we have money to invest the better quality device here because you need only one. Otherwise, you need a lot. Or the frequency bandwidth will be large. In this case, this one can be very narrow band, only around 455. Alright, next we discuss FM transmitter. The first one is called Crosby direct FM transmitter. what you have is a modulating signal, means the baseband signal or the signal we want to transmit. And this one here, there's a master frequency, 5.1, so FC equals 5.1 kilohertz. This one to here. And the low pass filter, this is discriminator. To okay, those are the diagram for Crosby direct FM transmitter. We have modulating signal, the music we want to transmit. This is a master oscillating oscillator. The frequency equals FC equals 5.1 K. And we have crystal here. This is the frequency equals 14.3 meg. We use a buffer and multiply by 2. So this frequency here equals 28.6. Just double the frequency. And we have this one frequency. First one multiplied by 3, factor of N1. Then multiply by 2, actually it's multiplied by 6, but you do 1 by 1, a little bit more stable. Then the frequency here will be equals 5.1 times 3 times 2 equals 30.6. 30.6, and this one is 28.6, so we have mixer here, and we use band pass filter to take only 2. And this one here, so the frequency will be 30.6 minus 2.6 equals 2. So this is just like a phase detector or something. Right? So we have a low pass filter. We are going to have an output if the frequency is not equal to 2 meg. Right? And then this one will control this frequency. If the difference here is not equal to 2, then we are going to have output here. Then this one will control the oscillating frequency. So make sure this one is very stable. Also stable compared to this one. Once we have this frequency here, then we multiply by 3. So 30.6 times 3, then that one equals 91.8. And we pass through a power amplifier, make the output power bigger. Then we output this one to an antenna. So that one is FM transmitter. Alright. The next one is Armstrong indirect method. The principle will be discussed in next chapter. How we get this Armstrong algorithm. Here we only list the diagrams. So the first one, there's a crystal here. And this frequency equals to 200K, it's very stable. Then we have amplifiers. Amplifiers, buffers, they work together. And this one here, and there's a phase shifter, negative 90-degree phase shift. Then this is a modulator, and this one is your modulating signal. This is the modulating signal, so that is the message. We can write the message. The message, for example, from 0 to 15K, like a voice. And this one here, we are going to have a combine called add up together. This one is a mixer, means multiply together. This is a combine, so add together. We discussed a lot of, in the first chapter, the amplifiers, operational amplifiers, how the two input can be added up together, right? So add. And then we have this band pass filter. I always put somewhere here. Then this one is multiplied by 72 multipliers, frequency multipliers. Then we have like a mixer and a converter. And this one, there's a crystal here. This one is 13.15 meg. This one is the amplifier, makes it larger. And this one is mixer. And this. So if this one equals up to 200K multiplied by 72. So this one will be equals 14.4 here, meg. And this one equals 13.15. And mixer here, we use the difference. So this difference here, that is here, this one will be equal to 1.25. So 1.25 meg. Then next one is we multiply 72. Then we have some band pass filter here. Then we have a power amplifier. Then we go to, that's it. So 1.25 times 72, that equals 90 meg. So this works for 90 meg, this channel. If you have different channels, you can choose different multipliers. Next one, last one is called double conversion. FM receiver, and we have an antenna here, and we have pre-select, and we have RF amplifier. And we have the first mixer. And we have the first oscillator. We have a buffer here. Then we have this. Then the output, we have band pass filter. So this is called first intermediate frequency. Then here we have a second mixer, and this one has the same thing. Buffer, right? Second oscillator, and this one give us we followed by band pass filter, and this one is RF amplifier, and again band pass filter, and there's a limiter. Then there's a because the modulator. Then there's the emphasis. And then audio amplifiers. Then this goes to speaker. And from the limiter, and we are going to have this. It's called automatic gain control voltage. The diagram looks like this. Pre-select a channel, then RF amplifier, then we have first the oscillator, local, then mixed together we have first the intermediate frequency, then the second local oscillator, okay, buffer amplifier, then second mixer, then we have band pass filter. Okay, this one is the final intermediate frequency amplifier, band pass filter. Then we have limiter here, and we use this one here to, if the output is very large, we don't want that, right? If the output is large, as we said, we may have extra noise, right? Then this one will control the gain here and the gain here. If this one output is large, then this gain will be smaller. If this output is small, then this gain will be larger. So keep the output stable. Then we have a demodulator here. Then we may have some other functions. Right? It's called the emphasis. That means we have some emphasis that were already. The emphasis, and the last one is the audio amplifier. Then once we get this signal is large enough to drive the speaker. So this is the double conversion. We have the first conversion, the second conversion, double conversion FM receiver. Okay, I think that's all for the systems. Thanks.
There's